Okay, this is activity JH19, and let me remind you that in the earlier two activities, we had the block traveling by itself according to some kind of rule like what you have up there, and a propeller which was also turning, or an arm which was turning about the base at some other type of a curve. What we want to do now is to put these two together so the block travels according to that description and the arm rotates according to the description shown below it. You just have to write a few lines of C code in order to get these things going. But I want to point out to you that because the places where these change are at the same location, 4, 6, and 4, 6, it's it's possible to put both of these commands in the same C subroutine or C program. But if they change at multiple locations which they don't coincide, one might be better off to put these commands in separate rules. Okay, and that is going to be the final activity of this week that I'm away. But anyway, right now I'm going to do this thing, but put both of these commands in the same C routine, in the same rule. Okay, so let's go ahead here, and we're going to uh, create the assembly. Immediately, I'm going to save this thing. File, save management. Save as. I have a folder for this, which is called JH19. All right. Let's insert the track first. Insert a new part in there. That's just going to be the track. Right click properties, track and track, or you can call it base if you want. Okay. Let's double click on it. And on that vertical plane, I will sketch just a rectangle. The size of these things are irrelevant to us. So I'm going to exit and pad it. Okay, so let me make this thing 15 or 10. 15. Okay, let's see how it looks like. Okay, something like that. All right, that's fine. Let me make it 10 actually. All right, all the way to the top. Let's insert the block. So insert new part in there. Right click block, properties, block and block. Excuse me. Double click on this. On that same vertical plane, I will make sketch. Why don't I draw a rectangle, another rectangle. We're going to put it there in a minute. Okay, something like that. Exit and pad it. Okay, that's fine. And on top of that, I'm going to make a pocket, or let me make a hole. How about that? Make a hole here at that location. Oh, that's too big. So let me make this thing 0.2. So it looks like, oops, what did I type here? 0.2. Good. That's all the way to the top. All right. And I'm going to insert the next part. And I'm going to call it the propeller. Properties, prop and prop. Okay, let's make it. On that plane, we'll sketch. Okay. Maybe something that looks like this. Fine. All right, and you know what? I'll make also a little circle here. Exit. Okay, let me do a quick multipath here. This is the big boundary. I'll make that thing maybe point 3, and this is the shaft. Oh, yeah, this is the shaft. I'll make this thing maybe point 0.5. Okay, so it looks something like that. All right. Okay, so let's go ahead and assemble these things. So all the way to the top. Let me go to the assembly design, and I'm going to anchor the track coincident between this edge and that edge, and coincident between this plane and that plane. That's going to make it prismatic joint. Good. And then coincidence between this axis and that axis, and coincidence between this plane and this plane. Update. I want it to go the other way around. Let's flip the arrows and update. That looks more respectable. All right. So all the way to the top, save everything. And now we're going to go to the digital markup, DMU kinematics, get the magic wand out, new mechanism, auto create. There's going to be two joints. One of them is going to be prismatic, the other one is going to be revel. You can check that. That's why the degree of freedom incidental is 2. All right, let me hide these things or collapse them. All right. Okay, so uh, these we're going to make it. This is a 2 degree of freedom system, so I'm going to make this thing angle driven. The propeller. That really doesn't matter. And this one is going to be length driven. Flip this so that it goes the other way around. Okay. Okay, mechanism can be simulated, and needless to say that when you simulate it or manually, there's two sliding bar, one for propeller, the other one for the oops, yeah, the other one for the block. Reset it. Okay, good. So how are these tied together? They're tied together to time, to the variable time through these things. Okay, and because I mentioned that in this problem it doesn't matter, I can both of these commands in the same rule. So where do we put the rules? You go to start, knowledge where, knowledge advisor. Here is the way you make rules right there. This is rule number 1. There's only one rule here. Okay, we're going to put it in one. Both combined. Okay, how about that? I'll call it combined. Good. Okay. So if you click on the mechanism, all the stuff related to the mechanism is going to pop up. Okay, so here's the way it goes. If time is less than, now if you go to that sketch that I had, less than 4 seconds, 4 seconds. Now, because I want to put two things, two statements in this if condition, I need braces. So I hit enter, I introduce braces. Now I can write both of those things in this single brace and close it. Okay, so let's worry about the variable, for example, length. There's the length. So this thing, by the way, if it's bothering you, you can put a tab here, is equal to, if you look at if you look at this drawing, okay, the velocity is 2 inches in 1 second. So 2 in underscore s Okay. Now, you might say, do I have to write it as 2 times 1 inch per second? We'll find out. If we get a syntax error, we're going to fix it. Okay. So this thing, times, don't forget the variable time. Okay, it jumps to the left. I don't like it, but that's okay. And then the next one is the other command. So angle equal to, if you look at that diagram, it says 180 degrees per second. 180 DEG underscore S times, okay, times time. So here's the variable time. Now, I'm going to close the braces and say okay if it gives me syntax error. Okay, so close it. Where's that? Braces, right there. Incidentally, all of these things that you see here, braces, if, else, etc., they appear as keywords and things like that. So if you ever forget, you can go get it. For example, if we can see that, okay, and there are some other things that allows you to, yeah. So there's stuff like that. But anyway, I don't say okay. Let's see if it gives you error message. No, it okay, okay, no problem. All right, let's go back here and do the rest of this. All right, else if, okay, the variable time is less than, what is that? You look at the drawing, 6 seconds. 6s, enter, braces. The block is going to sit stationary. So where is that thing? So this is length is going to be, it's going to sit there, which happens to be, what is that? It looks like it is 2 to 8. It's going to be at location 8 inches. 8 inches. Okay. Enter. And angle seems to be 180 times 4, 720. Yes, seems to be 720. Okay. 720. So angle equal to 720 DEG. Don't forget the DEG. Close the braces. Okay. So by the way, here you can do compile to see if there are any syntax error. We're not going to do that. I'm just going to close it. You can instead use this, find out, see what there's, if there's an issue, but I'll leave it like that, no problem. Okay. And then else, so anything past 6 seconds, uh, so you need braces. Go to the next line. Go to the next line. Braces. Where is your length? There is the length. Okay. Equal to. It was at 8 inches. 8 inches minus. You look at that velocity. It's going to be minus 2 inch per second. 2 inch underscore second times parentheses. There's a variable time. Don't forget the shift. Minus the shift is at 6 seconds. Okay, 6 seconds. If you make a mistake when we plot the command and it doesn't look what it's supposed to be, obviously we have a mistake in the formulas that we typed. And then the angle equal to 720 minus, now it goes at 90 degrees per second, 90 DEG underscore S times parentheses, time, minus same thing, minus 6 seconds of ship. Now, remember last time I closed this thing? Oh, uh, don't forget the braces, close the braces. Because this parentheses is here. Yeah, yep, yep, excellent. Because there's a parenthesis for this time minus 6 seconds and there's braces. Now, I close it. If I say okay and I get a syntax error, I have to go fix it. Otherwise, let's try to do this. It said highlight syntax error line, etc., etc. And didn't get anything. No syntax error. We say okay. Whoops, we better go and check some. There was no syntax error, but something wrong about units. So we say, okay, let's go there and find out where the inconsistency is. So that's C now. Let me move this thing up so that we can see the rest of this. Okay, good, good. So let's see. So this is, let me see now. This is length equal to length, no problem there. Degrees equal to degrees because it is 180 degrees per second times time, so that makes a degree equal to degree. Down here, length equal to length, angle equal to angle. Good. Let's go down here. It says length equal to, that looks good. Yes, that looks good. Down here, angle equal to, oh, right here, 720 DEG. Notice that syntax error did not pick this up, but when we try to run it, it says that there is a units don't match. So this DEG was missing. Say okay. Good, excellent. So now we're going to go and do simulation with laws and activate sensor. These two are the commands that we gave. Let's activate both of them over a 10-second interval. So what happens is that the first, based on the rules that we have, the first 4 seconds, this is going to go, the block is going to move, the propeller is going to turn, and then for the remaining 2 seconds, they both sit still, and then again it picks up and going in the other direction though. Okay, so let's see now. We zoom in here so that we can see it better. So let's run it. It sits there, and then it goes back, and yep. And notice that the rotational direction of the propeller also changes. Now, if I go here and I say graphics and I don't get those two graphs, I've done something wrong. And believe me, these are the same thing. Check the numbers too. All right, that takes care of this problem. And what in the very last activity of this week, week 9, I will do the same problem, except that I will create two rules, one for the propeller, one for the block, and instead of putting both of them in the same. Okay. All right. Good luck.